Okay, so hello everyone. My name is Kunal and I am your mathematics tutor. And today we are going to start actually the lecture number third of application of integral. So let me recap the things कि हमने अभी तक क्या क्या पढ़ रखी हैं. So let me recap quickly. So हमने अभी तक estimation देख रखा है. Estimation of definite integral जिसमें हमने 3 केसेस देखे थे. For if our integrand is monotonic increasing, if our integrand is monotonic decreasing, right? And the third thing we are कि like अगर हमें दी नहीं हुई है कि हमारा जो integrand है वो monotonic increasing है या decreasing है, so we actually proceed on by checking the things like if it's by finding its max and mean value. राइट तो ये सारी चीजें हमने देख रखी हैं. सो इन टुडेज लेक्चर वी आर गोना डू वन थिंग. आवर न्यू application, we are going to learn a new application of integral, which is actually determination of function. Okay, so we are going to do today our new application, which is determination of function. So let me write a quick question and try to tell you how to approach or solve this kind of question. So our question given is find a function f which is continuous function for all x, and one thing is given fx is not equal to 0 for all x, and such that our fx whole square is equal to integration of, we are doing from 0 to x, f of t sine t divided by 2 plus cos t. Okay, so you have to calculate this. So we all know that. So you have to actually calculate this function. ये actually function है क्या? Right. So we are gonna actually using the things that we are already learned in our definite or indefinite integration. We are actually use this thing to for an application basis. Okay. So we all know that if we are in, this is the form of like Leibniz. So what I am doing just differentiate the LHS and RHS. So when we differentiate the LHS and RHS, then what would you get? So let me differentiate with respect to x, right? So when we differentiate, what we get 2 of fx, and then we applying the chain rule, which is f dash of x. And when we use the Leibniz here, because we all know that like d by derivative of antiderivative, right? So this is the derivative and we are taking the antiderivative of this integrand. So we are all using the derivative of antiderivative, which is also known as differentiation, basically Leibniz rule. So let me apply it here. So you all know that how to apply. Put the upper limit here. So when we put that, what we get f of x sine of x divided by 2 plus cos of x. Right. I hope you'll all understand this, what I'm trying to say. And okay. And now what you have to do, and when we do that, so this is our form. So this fx and this fx got cancelled. So what we get? 2 of f dash x is equal to sine x by 2 plus cos x. So when we integrate this with respect to x, so let me take it here dx and integrate both sides. So what we get? We actually get 2 of f of x is equal to integration of sine x divided by 2 plus cos x dx. So when we integrate this, what we get? Minus of ln 2 plus cos x. I'm writing direct because you all know how to integrate this function. Let this function be f. So the a function will be df. Okay, so 1 by f will be ln f. So our fx is something look like this is by 2. And now we all know that like f0 is equal to 0. So there will be like 2 into 0 is equal to minus ln of 3 plus constant. So our constant is nothing but ln 3. So when we get through the actual function, what we get? Fx is equal to, there will be 1 by 2 there will be ln 3 by 2 plus cos x. I hope we'll all understand this, what I actually did here. Okay, so let me explain it again. So it will be clear to you. So मैंने क्या करा कि हमें जो था वो ये एक एक्चुअली इंटीग्रल के फॉर्म में कुछ तो एफ एक्स का होल स्क्वायर दिया हुआ था एंड वी हैव टू फाइंड द एफ एक्स। लाइक मेरा फंक्शन है क्या, ठीक है, अपन को यही निकालनी थी कि फंक्शन है क्या। सो मैंने यहाँ पे क्या करा कि एक्चुअली हमें we have to use the concept of the definite and indefinite integration here. So what I did here, I know that this is the form. If we differentiate this RHS, so it will be like form of derivative of antiderivative. Okay, so I'm in Leibniz form. So what I did here, I just differentiate the LHS and the RHS. Okay, with respect to x. So when I do that, like do f of x, we applying the chain rule. यहाँ तक तो समझ में आ रही है ना? We are applying the chain rule here. And then what I did, and then I integrate because we get the f dash of x. And I know that when we integrate the f dash of x, what we get? We get f of x, right? We get the f of x. Now what I'm trying to say, just integrate it, and it's a basic integration. And one thing is given, like f of 0 is 0. So you can easily get the function. I hope this is clear to you. Okay, now let's move on to the problem number 2. इसमें भी आपने वही फंक्शन निकालनी है. जस्ट यू हैव टू यूज द कॉन्सेप्ट ऑफ डेफिनेट एंड इनडेफिनेट इंटीग्रेशन, क्योंकि यहाँ पे देखो दोनों कॉन्सेप्ट यूज हो रही ना. सो यू हैव टू जस्ट यूज द कॉन्सेप्ट ऑफ डेफिनेट एंड indefinite integration. Okay, so let me take the new question here, which is something look like if f of x is equal to x plus xy square plus x square y fy dy. Okay, so you have to calculate find the value of f of x. So you have to find the value of f of x. यहाँ पे अपना ये जो दिया हुआ है ना, मतलब ऐसा कुछ कॉम्प्लेक्स वर्जन दिया हुआ है कि तुम्हें एफ ऑफ एक्स निकालना है, मतलब तुम्हें एक्स की फंक्शन निकालनी है, बट हियर गिवन इज समथिंग लाइक एक्स प्लस देयर इज आल्सो द वाई टर्म आल्सो. सो हाउ डू यू डू दैट? दिस इज द थिंग दैट यू हैव टू लर्न. सो लेट मी टेक माय अप्रोच, जिससे आपको क्लियर हो जाए कि मैं कर क्या रहा हूँ. ओके, सो माय सजेशन इज कि पॉज द वीडियो and try to solve it by own, and otherwise मैं तो solve कर ही रहा हूँ. So okay, let me solve it here. Okay, so let's begin the chapter. Let's begin the uh, this problem solving. Okay, so it will be something look like what I have to do. Just write fx is equal to take the x common, right? So what I'm doing here, when you do that, what we will get? We will take x common. So we'll get 0 to 1 y square plus there will be like let me write it here, multiply by this also. Okay, so let me raise it first. So there will be like y square f of y dy. Okay, and then plus take out x square outside. So what we get? Integration of 0 to 1 y f of y dy. Okay, so if you look at here, we have to calculate the x term, right? We have to calculate the f of x. So we can assume the integration of this term will be something a, and integration of this term will be something b. I don't know what it is. इस स्टेज पे हमें नहीं पता है कि इसकी इंटीग्रेशन क्या है, बट इट कैन बी इंटीग्रेबल बिकॉज इट इज इंटीग्रेटिंग y and a function of y is integrating in with respect to the elementary element dy. So its integration will be something a. So what I am assuming here, when we integrate from 0 to 1 y square f of y dy, so its integration will be coming something a. And the next thing is when we are integrating from 0 to 1 y of f of y dy, so its integration will be something b here. So how our fx now look like? if I write it in a good way, so our fx will be something look like x plus ax plus bx square, and this is our equation number 1. Okay, so now what you have to do, let me write it here the a and try to find it out the value of a here. Okay, so let me write it here. So how can we write as a a? So our a will be something look like we are integrating from 0 to 1 and y square. Now what's the value of fy? Anyone you know? We know that. Look, the f of x is, when we substituting the x, it will be something look like this. So when we put the f of y, so f of y means replace x by y. Just it means kya hai? Replace, do nothing, just replace x by y. So when we do that, replacing x by y, what we get? Y plus ay plus by square. I hope you'll all understand this, what I'm trying to do here. Right? So we have to write here y square fy. So our fy is nothing but y plus ay plus by square dy. Now what is our b? Our b is we are integrating from 0 to 1 and f of y dy. So y into an f of y is nothing but y plus ay plus by square. Okay, so now on, solve these two equations. Solve these equation to get a relation between a and b, and then try to find the a and b. So how to do that? Right. So let me write it here. So our a is equal to, let me move on from the a. So our a is equal to nothing but we are integrating it from 0 to 1, and let me multiply it inside, right? So it will be like y cube plus ay cube plus by to the power 4 dy. Let's integrate it. So what we get? Y4 by 4 plus a by 4y4 plus by to the power 5 by 5, right? And we are integrating it from 0 to 1. So what we get? We get a is equal to 1 by 4 plus a by 4 plus b by 5, right? So what we will get from here? We get 3a by 4, a minus a by 4 minus b by 5 is equal to 1 by 4. So this is our equation number 1. Now move to the b. So our b is actually is equal to nothing but we are integrating it from 0 to 1, y into, so let y into y plus ay plus by square. So let me multiply it inside the bracket. So what we will get here? We will get nothing but we are integrating it from 0 to 1, y square, ay square plus by cube dy. And when we integrate this, what we will get? We will get y cube by 3, ay cube by 3 plus by 4 by 4, 0 to 1. So our b is nothing but it will be equal to 1 by 3 plus a by 3 plus b by 4. And when we solve that, what we get? We get minus of a by 3 plus of 3b by 4 is equal to 1 by 3. Right? So from above two equation, on solving equation 1 and actually I think 1 I take some more, okay, so let me take it equation number 2. Let me question equation number 2 and let me take it equation number 3. So when we solve equation 2 and 3, okay, so what we will get? We will get the final answer as something fx is equal to x plus ax plus bx square. So when we solve this, we get the value of b is equal to 80 by 119. And the value of x is actually nothing but something like we have to calculate the 1 plus a now. So 1 plus a value will be something like 180 by 190. So when we for the fx, so our function is nothing but 180 x by 119 plus 80 by 119 x squared. So this is the correct example and the easy example of nothing but what is called determining the function. So let me tell you again what I'm doing here. So actually this is our given an expression given, right? And you have to find the function fx. So what I did here, I first multiply fy inside and then take the x outside. We can do that, right? So we can do that. And what I'm assuming, I am assuming key the integration of y square fy from 0 to 1 will be something a. And when we integrate the function fy from 0 to 1 with respect to elementary element dy, so its value will be something b. Okay. Now, so our fx now look like something like x plus ax plus bx square. So the same thing I written here. So what if the fx is equal to x plus ax plus bx square? So what is our ay? Now basically fy. So the fy is also equal to y plus ay plus by square, right? I hope you'll all understand this, what I'm trying to say here. So it will be something look like, like x tending to y. So our the fy is equal to something. Now what I'm doing here, I just write the a. So what is our a? So our a is nothing but y square fy dy. So write it here, y square, and the fy is nothing but y plus ay plus by square, which is there. And then we integrate this. So on integrating, we get a relation in a and b. Similarly, when we calculate the b, we get another relation between a and b. And when we solve this and put it in here, put it in equation 1. So, and put it in equation number 1. So what we will get? We will get the final result. So this is our principal equation. You have to put the value of a and b here. Okay, so I hope you'll all understand this, what I'm trying to say. So, okay, now we are going to learn the new application, which is application number 3rd, which is actually the average value of function. Let me tell you clearly. In via tomorrow class, we are gonna learn our area. It is also an important application of इंटीग्रल जो हमने पहले भी देखा था ज्योमेट्रिकल इंटरप्रिटेशन ऑफ डेफिनेट इंटीग्रल में। तो आज जो है ना अपन क्या कर रहे हैं कि जो भी और भी एप्लीकेशन होते हैं ना एरिया के अलावा जो कि एग्जाम में पूछे जाते हैं, जैसे एस्टिमेशन ऑफ डेफिनेट इंटीग्रल हो गया, तुम्हें फंक्शन कैलकुलेट करने के कि फाइंड डिटरमाइन द फंक्शन, एवरेज वैल्यू। सो दीज आर दी important topic of which is application of integral. Okay, like if आपको कह दिया sin square x की average value बताओ, so you have to use the integrals to find out the value of sin square x, average value of sin square x. Okay, so let me write it here. We are doing the new application which is average value of function. सो हमने अभी तक क्या क्या कर रखा है एक बार सोचते रहो। हमने एस्टिमेट कर लिया द वैल्यू ऑफ डेफिनेट इंटीग्रल का, उसमें भी हमने 3 केसेस देखे। उसके बाद हमने फंक्शन को डिटरमाइन करने आ गया, लाइक फंक्शन फाइंड करनी है किसी कॉम्प्लेक्स फॉर्म में लिखा हुआ, एक्सप्रेशन के फॉर्म में दी हुई है, इंटीग्रेशन के एक्सप्रेशन के फॉर्म में दी हुई है, देन वी नो हाउ टू calculate and to find the function, right? So let me write it here, the new topic, and which is also the application of integral, which is average value of the function. And the second thing, we have to find the root mean square. So वो भी अभी हम करेंगे. So let me try out to find out the value of average value of any function. So what is yf? So let me try to write it here. Let us suppose our y as a function of x. This is a function given. Okay, so what is the value y average value? So we also write this as in this form. So ये या तो y एवरेज लिखो या फिर लेस देन सिंबल एंड ग्रेटर देन सिंबल एंड बीच में y. So this is also known as the y average. I mean the average value of y. So this value is actually equal to integration of fx dx from a to b. हम अभी इसके इम्प्लीमेंटेशन को भी देखेंगे, लाइक हाउ टू इम्प्लीमेंट दिस फॉर्मूला, but try to write it. So this is our average value of any function. Okay, so whenever you have to find the average value of any function, you have to apply this formula. Okay, so let me take the example here. Okay, so you have to find question, find the average value of y is equal to sine square x from 0 to pi by 2. Basically, the graph of our sin x is something look like that. There is 0, there is pi, there is 2 pi. Everyone knows, right? And there is the value pi by 2. And at pi by 2, the value of y is 1. So we have to look, actually we have to find the average value in this region. So what is the average value of sin x in this region from 0 to pi by 2? इस रीजन में sin x की एवरेज वैल्यू क्या है? Okay, so you have to find it out. So what I'm trying to do here is we have to just apply this formula. So like basically for sin 0, 0, sin 30, 1 by 2, right? And sin 45, 1 by root 2. So let me tell you one thing. ये फॉर्मूला आया कैसे? Okay, so आपको और अच्छे से समझ में आएगी. मैं अब जस्ट बता रहा हूँ. Okay. Okay. Let's do it here. So let me apply the formula. We can write the y average or we can write y average. So it's nothing but we have to, and noted that our a is here 0 and the b value is pi by 2. Okay, so let us continue. So our y average is we have to integrate from 0 to pi by 2 sine square x dx and divided by b minus a. So our b is nothing but pi by 2 and minus a is nothing but 0. And we all know that हमने डेफिनेट के फर्स्ट क्लास में पढ़ रखा है Wallis formula for sine to the power nx, and we are integrating it from 0 to pi by 2. So here the power is even, so we have to multiply it by pi by 2. So what I have to do here, 2, 1, and we have to multiply it by pi by 2. What I am doing here, I just apply the Wallis formula. अब यही सारी चीजें एप्लीकेशन में आपको डायरेक्टली लगाने आना चाहिए, है ना, कि मैं कौन सी फॉर्मूला लगाऊं कि मेरी चीजें, अब मैंने बहुत सारे डेफिनेट में प्रॉपर्टीज वगैरह बता रखे हैं ऑलरेडी, सो आई एम यूजिंग हियर डायरेक्टली. और अगर आपको कोई भी डाउट हो तो आप डेफिनेट इंटीग्रल के जो भी प्लेलिस्ट है उसमें जाके फर्स्ट सेकंड थर्ड लेक्चर जिसमें भी हो आप देख सकते हो. ओके, सो देयर विल बी लाइक 1 by 2 pi by 2 and there is the for the value pi by 2. So this get cancelled, so we get the average value is 1 by 2. Look at here. So what we get the average value of y, which is the average value of sine square x, is equal to nothing but 1 by 2. So this is our average value. So let me tell you something कि actually हम यहाँ पे कर क्या रहे हैं. सो आपने पहले लाइक अगर हमें पास नंबर दिया हुआ था, लाइक मान लो 10 नंबर दिए हुए हैं, 1 2 3 4 5 6 7 8 9 10, एंड आपको जो पहले क्लास में बोला था कि इसकी एवरेज निकालो. सो व्हाट यू ऑल डू, हम क्या करते थे, हम इन सारों को ऐड करते थे. आई मीन आवर एवरेज वैल्यू फॉर्मूला इज we take the summation of each term and then divided by number of term. यही करते थे ना. तो ओके, सो बेसिकली यहाँ पे अपन क्या करते थे, 1 + 2 + 3 + 4 ... 10 and divided by the number of turn which is equal to 10. So how we get that? N into n plus 1 by 2, right? So there will be cancel and the 11 by 2 is 5.5. यही तो करते थे ना अपन, यही तो कर रहे होते थे ना. N into n plus 1 by 2, you all know this formula ना. Sum of natural number will be summation of basically n into n plus 1 by 2. Okay. नाउ तो यहाँ पे क्या हो रहा है ऐसा, लाइक अगर तुमसे कोई कहे कि साइन एक्स की वैल्यू निकालो, एवरेज वैल्यू, सो यहाँ पे हो क्या रहा है, एंड गिवन इज 0 to pi by 2. सो लेट मी ट्राई टू विजुअलाइज यू एक्चुअली हो क्या रहा है. लेट मी मेक अ क्लियर फिगर हियर. दिस इज एक्स एक्सिस and this is y axis. Okay, so this is the graph of sin x. There is the value 0, there is the value pi, there is the value 2 pi, and there is something pi by 2. Now हमें साइन की 0 से pi by 2 के बीच कितनी वैल्यू पता होती है. इन जनरल हमें साइन 0 की वैल्यू पता होती है, साइन 30 डिग्री की वैल्यू पता होती है, साइन 45 डिग्री की वैल्यू पता होती है, और साइन 60 की वैल्यू पता होती है, एंड साइन 90 की वैल्यू पता होती है. 1 2 3 4 5 वैल्यूज हमें पता है. बट क्या 0 to pi by 2 के बीच में, 0 to pi by 2 के बीच में बस इन्हीं 5 एंगल एग्जिस्ट करते हैं? माय क्वेश्चन इज, क्या 0 to 5 के बीच में क्या बस यही 5 एंगल एग्जिस्ट करता है जो जिसकी वैल्यू हमें इन जनरल पता होती है? लाइक साइन 0 0 होता है, सबको पता है. साइन 30 डिग्री 1/2 होता है, साइन 45 1/√2 होता है, साइन 60 √3/2 होता है, एंड साइन π/2 1 होता है. वी ऑल एवरीवन नो. बट क्या साइन 15 डिग्री एग्जिस्ट नहीं करता है? साइन 1 डिग्री एग्जिस्ट नहीं करता है? साइन 2 डिग्री, साइन 3 डिग्री, साइन 3.5 डिग्री, साइन 3.1 डिग्री. समझ रहे हो मेरी बात को? ये सारी भी तो एंगल एग्जिस्ट कर रही हैं. In general, what we are doing here, we are actually finding the average value. And we know that when we find the average value, we add the each and every term. But here the things is कि हमें सारी टर्म नोन थी. जितने भी टर्म का हमें एवरेज वैल्यू निकालना था वो सारे टर्म नोन थे. बट द थिंग्स हियर इज कि हमें सारी टर्म नोन नहीं है, हमारी कुछ वैल्यू पता है हमें, एंड मोस्ट वैल्यू हमें पता नहीं है. लाइक इफ वी नो लाइक हाउ टू कैलकुलेट साइन 3.1 डिग्री, इसकी वैल्यू हमें पता नहीं है ना. बट ये एग्जिस्ट कर रहा है 0 to pi/2 के बीच में. समझ रहे हो? तो मैं बस यही कहना चाह रहा था कि अलॉट्स ऑफ वैल्यू यहाँ पे 0 to pi/2 के बीच में प्रेजेंट है साइन की, बट उसकी वैल्यू हमें नहीं पता है. बट यहाँ पे जो स्कूल में हम निकालते थे एवरेज वैल्यू लाइक 1 to 10 का या कोई भी 10 डिजिट का मीन वैल्यू निकालते थे. सो द डिफरेंस इज कि वहाँ डेटा हमें नोन होती थी कि हमें इसका एवरेज निकालना है. सो वी टेक दी नंबर एंड add those and then divided by the number of term. बट यहाँ पे तो हमें टर्म नोन है ही नहीं, बहुत सारे टर्म नोन नहीं है. सो व्हाट आई एम ट्राइंग टू डू, मैं ऐसा करता हूँ कि we all know that when we integrate with a certain element like dx, so what I did here, I just replace are you remember the things like when we read the indefinite integration, sum of limit of finite sum. लिमिट ऑफ फाइनाइट सम मैंने पढ़ाया था, जिसमें कुछ इस तरह की टर्म होती थी जहां पे अपन रिप्लेस कर रहे होते थे. याद है? r/n को x से, r/n को x से, 1/n को dx से, है ना. एंड देन समेशन को इंटीग्रेशन से, फिर उसको लिमिट निकालते थे. लोअर लिमिट कैसे निकालते थे, अपर लिमिट, ये सारी पता है. लिमिट एंड टेंडिंग टू इंफिनिटी r/n वैसा करके. So what I'm trying to do here, I just replace summation by integration. Okay, so what I get here, I get fx dx from a to b, and the simple thing, I just add the each and every single element from a to b. So when we integrate this, what we get, a to b fx dx, and in denominator we get x from a to b. So it will be something equal to, when we integrate from a to b, f of x dx, and it will be equal to b minus a. Right? I hope you'll all understand is what I'm trying to do here. I just connect it with जो आपने स्कूल में पढ़ा होगा कि एवरेज वैल्यू निकालते थे कैसे, टू ट्राई टू कनेक्ट विद द integration. So this is the application. Okay, so you have to uh, use it. Now the next application is, हमने यहाँ पे क्या क्या देखा, हमने देखी डिटर्मिनेशन ऑफ फंक्शन, किसी फंक्शन को कैसे डिटरमाइन करते हैं, right? And then the average value of any function. Now we are gonna find a new thing which is actually, let me write it here. I think I choose the wrong. Okay, so let me write it here. Okay, I choose the marker, I guess. Okay, so the root mean square. What is it? Root mean square. Okay, so root mean square क्या होता है आप सभी को पता ही होगा. आपने केमिस्ट्री में VRMS का नाम सुना होगा, विच इज ऑल्सो इक्वल टू √3 RT बाई मोलर मास, है ना. केमिस्ट्री में ये आप लोगों ने पढ़ा होगा. केमिकल जब आपने गैसेस वगैरह पढ़ रहे होंगे ना, तो ये आई होगी. तो वेयर द RMS यूज वर्ड, दिस RMS इज, वहां पे आपने पढ़ा होगा, दिस इज द रूट मीन स्क्वायर. लाइक दिस इज एक्चुअली VRMS. सो व्हाट इज द मीनिंग ऑफ VRMS? ये मैं केमिस्ट्री से कनेक्ट कर रहा हूँ. ओके, सो वहां पे VRMS क्या था? तो RMS इज लाइक वेलोसिटी, रूट मीन स्क्वायर वेलोसिटी ऑफ गैसेस, राइट? रूट मीन square velocity of gases. So this thing we are actually connected from there, right? So उसकी वैल्यू लाइक √3 RT by m आ रही थी, आपको पता भी होगा. So what I'm doing here, we are gonna find the root mean square of any function. Let me write it here in a clear way. Root mean square of any function, not just the velocity, but any function. Okay, so what its formula is? So its formula is something look like, let me write it here. The lambda RMS means the root mean square of any function. Okay, it is also an average value, but it is actually greater than average value. Okay, so let me write it here. It's something like a root under, let me write it in a straight way. Okay, so it will be something look like, we are integrating it from A to B, and there will be f square x dx and divided by b minus a. So this is the actually formula of root mean square. So अगर आपको कहीं पे भी sin x की निकालनी हो, okay, so यहाँ पे देखते हैं. So let me take an example here. Let me take an example here. Find the root mean square of function y is equal to sin x from 0 to pi/2, है ना. तो इसकी आपकी रूट मीन स्क्वायर वैल्यू निकालनी है. So what is our lambda RMS? So try to solve it. So my suggestion is to try to pause the video, है ना. Try to pause the video and solve it by own, and then try to match it. Okay, so it will be something look like, find the root mean square. So let me write it here. So the lambda RMS is nothing but root over, we are integrating from 0 to pi/2. There will be sin square x, because the function is sin x, so our sin square x dx, and it will be divided by b minus a. So the b minus a is nothing but pi/2. And we just solve this integral. So what we get on solving this integral, we are solving this integral by using Wallis. So we get the pi/4, right, in the RHS. So it will be something look like pi/2 into 1/2 divided by pi/2. So it get cancelled, and it will be 1/√2. So what we get here, actually, the lambda RMS, or the root mean square of the function RMS of y is equal to sin x is 1/√2, which is actually is equal to its sin 45 degree, right? Sin 45 degree कितनी होती है? 1/√2 होती है ना. So this is the RMS value of y is equal to function sin x. I hope these things are clear to you, right? So now let's move on to the next application, which is uh, which number? One, two. Okay, I think it's fifth number. Okay, so let me take the fifth application of integral. This is also known by differentiation and integration series. It is like differentiation, integrating series. Okay, so let me try to show you how to find and how to calculate the thing. Okay, so let's take an example. एग्जाम्पल सही समझ में आया क्योंकि इसमें कुछ थ्योरी पार्ट है नहीं. यू हैव टू जस्ट लर्न द अप्रोच लाइक कैसे सॉल्व करते हैं. तो उसी से चीजें क्लियर हो जाएंगी. सो लेट मी टेक द एग्जाम्पल हियर. So our question number one will be something look like find x square by 1 into 2 minus x cube by 2 into 3 plus x to the power 4 by 3 into 4, right? Plus dot minus 1 to the power n x to the power n plus 1 divided by n into n plus 1 and plus dot up to infinite. And the one thing here is given is mod x is less than 1. What it means? That means our x lies between -1 and 1. This is the condition here. So you have to calculate the sum of the series. ये जो सीरीज दी हुई है ना, इसकी आपकी सम की इसकी वैल्यू बतानी है. आप जैसे ही बताओ. सो एक्चुअली दिस इज द एप्लीकेशन ऑफ इंटीग्रल. तो आपको समझ में आ गया होगा कि यहाँ पे हम कुछ तो इंटीग्रेशन की लॉजिक को यूज कर रहे होंगे जो हमने अभी तक डेफिनिट और इनडेफिनिट में पढ़ रखी है. So the series is look like x square by 1 into 2 minus x cube by 2 into 3 plus x4 by 3 into 4, something. And our x varies from -1 to 1. Our x varies from -1 to 1. So what we have to do here? So we are actually not going to use only here integration. We have to differentiate it. So try to differentiate this. Let me solve it. So differentiate. So let me take it here first. It is something like y is equal to, okay, y is equal to something given. So differentiate LHS and RHS with respect to x. So this is the thing that you have to do here. So when you differentiate this, what you will get dy by dx is equal to 2x by 1 into 2 minus 3x square by 2 into 3 plus 4x cube by 3 into 4 dot up to infinite. So one thing we notice, this term get cancelled, right? So what we will get here? We'll get dy by dx x minus x squared by 2 plus x cube by 3 minus x4 by 4. We'll get this term up to infinity, right? And one thing we know that just in previous class हमने देखा क्या था? टेलर एक्सपेंशन देखा था ना? या आपको याद है हमने टेलर एक्सपेंशन देखा था? So the Taylor expansion of ln1 plus x is exactly same, which is written here like x minus x square by 2 plus x cube by 3 minus x4 by 4. So this is the up to infinite, right? So this is the actually Taylor expansion of ln1 plus x. So we can write this is equal to ln1 plus x. So what we will get here, this is actually, let me write it here. This is the Taylor expansion of ln1 plus x. Y is equal to ln1 plus x. Okay, I hope this thing is clear to you. So what we will get here? We will get dy by dx is equal to ln1 plus x. Now what you have to do? We have to calculate the y here, right? We have to calculate the y here. So take like dy is equal to ln 1 plus x and dx and just integrate this. So we all know the integration of ln x is nothing but x of ln x minus 1. So what you have to do here, y is equal to 1 plus x. Try to replace x by 1 plus x. So it will be like ln 1 plus x and there will be minus 1 minus 1 plus x. right? I hope these things are clear to you, है ना? So it will be something look like this. So now it's something look like there will be like 1 plus x. Let me write it here in a good way because यहाँ पे ज़्यादा ही empty हो रही है. Okay. So there will be -1 and plus some constant here, right? I hope these things are clear to you. So now what the next thing is? The next thing is our y is equal to 1 plus x ln of 1 plus x minus of x. So this is our value of y. We are just integrate and use the property of definite integers. So okay, so this is actually the series के term में कुछ भी term दी हुई होंगी and you have to calculate its value. So what you have to do, you have to think something. Either देखो यहाँ पे एक चैप्टर के कॉन्सेप्ट यूज नहीं हो रही है. So this is J advanced level question. We are using the differentiation, the concept of differentiation, the concept of definite integration, the concept of indefinite integration, and overall the complete question is made up of, which is belongs to the topic application of integral. इसका मतलब ये नहीं है कि सिर्फ इसमें इंटीग्रेशन आ रही होंगी, इसमें हम डिफरेंशिएशन की कॉन्सेप्ट भी यूज कर रहे होंगे. लाइक इन प्रीवियस लेक्चर हमने काफी सारे मल्टीपल चैप्टर के कॉन्सेप्ट यूज कर रहे थे ना. लाइक हमने पीएनसी परम्यूटेशन एंड कॉम्बिनेशन की कॉन्सेप्ट यूज कर रहे थे, डिफरेंशिएबिलिटी कॉन्सेप्ट यूज कर रहे थे, कंटिन्यूटी कॉन्सेप्ट यूज कर रहे थे, जनरल इनइक्वालिटी कॉन्सेप्ट यूज कर रहे थे. सो दिस थिंग आर यू हैव टू लाइक एक चैप्टर की क्वेश्चन नहीं होंगे, 2-3 चैप्टर को मिक्स करके क्वेश्चन बनाया हुआ है. ओके, सो यू हैव टू मतलब थिंक अबाउट इट कि पहले क्या करनी है. क्योंकि अगर पहले आप इसको इंटीग्रेट करोगे सो यू विल नथिंग गेट. बट अगर तुमने क्वेश्चन को देखा एंड यू एनालाइज कि इफ आई डिफरेंशिएट दिस, सो हमें क्या मिल रहा है, टेलर एक्सपेंशन मिल रहा है ln 1 plus x का, right? And when we differentiate, we get the Taylor expansion of log of 1 plus x, so we can integrate it in a good way, है ना? So I hope this thing is clear to you. So let me take the another example on it. So थोड़ी और क्लियर आपको क्लैरिटी आ जाएगी. So let me take the question number 2. 1 by 1 plus x plus 2x by 1 plus x square plus 4x cube by 1 plus x to the power 4 up to infinity. So let us take it as y. Now try to analyze it. Pause the video and try to analyze it कि क्या रिलेशन क्या है, क्या हमें डिफरेंशिएट करना चाहिए या यहाँ पे इस टर्म को देख के कुछ तुम्हें पता चल रहा है तो वो ही बस तुम्हें उसी चीज को पकड़ के तुम्हें आगे यूज करनी है. तुम्हें ज्यादा दिमाग नहीं लगाना, बस सीरीज को देखो और ट्राई टू एनालाइज इट कि क्या लिखी हुई है सीरीज में, क्या हम कर सकते हैं. दैट्स ऑल. सो माय सजेशन इज पॉज द वीडियो एंड ट्राई टू सॉल्व इट बाय योर ओन. और जब सॉल्व नहीं हो तब देन वॉच द सॉल्यूशन. So let me solve it here. If you think and watch this series carefully, so what you get, if this is our function f, so there is gf. If this is our function f, so there is gf. If this is our function f, so there is our function df. Like 1 plus x to the power 4 को हमने अगर f function मान रखे हैं, so our df will be something look like 4x cube because the differentiation of constant is 0. Its differentiation is 4x cube. So what I'm trying to do here is try to integrate. Like what I'm doing here, I just integrate the whole function. Our y is equal to function of x. So what I'm doing here, y dx. बस integrate कर दो. So it will be like ln 1 plus f because f and df के है ना, and we all know that the integration of 1 by f is nothing but log of f. This thing is clear to you. So it will be like ln 1 plus x plus ln 1 plus x square, right? This thing up to infinite. Okay, and the noted one thing is our mod x is given is less than 1. So it will be something like ln 1 plus x. Let me write it here. ln 1 plus x square 1 plus dot x to the power 2n minus 1. Right? अब ये कहाँ से है आपको पता ही होगा. अब देखो यहाँ पे हम क्या यूज कर रहे हैं अपन. we are using, look at here, there will be like 1 plus x square plus dot x cube, right? X to the power 4. So this is a GP, geometric progression of infinite term, जहां पे क्या है, our common ratio is x square and it's going to up to infinity. So we all know that the summation of infinite GP is nothing but 1 by x minus 1, right? So we are just using this concept and we get it to the power n minus 1. What is it? Like 1 by, and where x is the common ratio, है ना? So we just use the concept of geometric progression to solve this problem and we actually get that. And now, so we are using the concept of geometric progression here. Summation of infinite term of geometric progression. And now 1 minus 1 by r. Okay, so when you use that, you will get here. And now here we will like fx of things because y is also equal to fx. So integration of fx dx is nothing but when you solve this, what we get? ln of 1 minus x. And now if n tending to infinity, because देखो यहाँ पे अपनी जो n है, let me कहाँ गया, अपनी जो n है वो तो इनफाइनाइट तक जा रही है ना. So what we have to do, if n tending to infinity and mod x is as usual less than 1, so x to the power 2n is tending to 0. अब भाई तुम यही सोचो 0.01 की पावर 900 क्या ही होगा, लाइक 0.01 का स्क्वायर ही कर दो तुम, तो इट विल बी लाइक 10 to the power minus 4 because it 10 to the power minus 2 ना. So 10 to the power minus 2 to the power 100. It's like 10 to the power minus 200. It is tending to 0, right? Its value is tending to 0. है ना? So you all, I think, understand what I'm trying to say. So this value is tending to 0. Let me raise it here and then try to move on. Okay, so now we have to calculate fx. So what you have to do, differentiate the fx because there is the, we all know that like the differentiation of integral is integrand and the integration of integrand is integral. So we just differentiate this. So what we get on differentiating, what we will get, we will get f of x is equal to 1 by 1 minus x. So this is my answer. I hope you'll all understand what I'm trying to say. So आज हमने क्या क्या पढ़ लिया, आज हमने एप्लीकेशन ऑफ इंटीग्रल के 4 प्रॉपर्टी देखे. पहला प्रॉपर्टी हमने सीखा डिटर्मिनेशन ऑफ फंक्शन, दूसरा देखा एवरेज वैल्यू, तीसरा देखा VRMS लाइक रूट मीन स्क्वायर ऑफ एनी फंक्शन, नॉट VRMS इज फॉर वैल्यू, मतलब वेलोसिटी ऑफ RMS, राइट, RMS वेलोसिटी. बट हमने क्या देखा, लैम्डा RMS मीन्स रूट मीन स्क्वायर ऑफ एनी फंक्शन. एंड द फोर्थ प्रॉपर्टी आज हमने क्या सीखा, और एप्लीकेशन, not property, it is an application, and the fourth application is differentiating and integrating series. So अभी तक हमने टोटल 8 एप्लीकेशन ऑफ इंटीग्रल देख चुके हैं टिल नाउ, है ना. 8 एप्लीकेशन ऑफ इंटीग्रल हमने देख चुके हैं टिल नाउ इन जस्ट 3 लेक्चर्स. सो नाउ ऑन अपना जो आने वाला जो 4 लेक्चर्स होंगे, वी विल डिस्कस अबाउट द एरिया, जिसके बारे में मैंने पहले बता रखा है, ज्योमेट्रिक इंटरप्रिटेशन ऑफ डेफिनेट इंटीग्रल, राइट. उसकी फर्स्ट लेक्चर में मैंने बता रखी है. तो ट्राई टू वॉच द फर्स्ट वीडियो ऑफ डेफिनेट इंटीग्रल, जिसके बाद ये और भी अच्छे से कल समझ में आने वाला है. सो दैट्स ऑल फॉर टुडेज गाइस. सो इन टुमारोज लेक्चर वी आर गोना स्टार्ट द 9th एप्लीकेशन ऑफ इंटीग्रल विच इज एरिया अंडर कर्व. So we will gonna start it tomorrow. So try to revise it and try to solve more and more problem on this so that it will be understandable and clear to you. I hope you'll all understand these things. So these are not like one-liner problem. We are actually देखो नाम में क्या लिखा है, एप्लीकेशन ऑफ इंटीग्रल. सो आपको इंटीग्रल्स के प्रॉपर्टी, ट्रैक अप्रोच कैसे करते हैं, मैंने सारे कुछ बता रखे हैं. तो बस आप में देखो, अगर वो सारी चीजें करी हुई होंगी तो यहाँ पे ज्यादा हेक्टिक लगी नहीं रहा ना. हमें ये देख के लग रहा है कि ये एफ है, ये डीएफ है, वी ऑल नो दैट कि अगर इंटीग्रेट करेंगे तो डीए बाई एफ का इंटीग्रेशन कुछ नहीं होता है, बस एल एन एफ होता है, मॉड ऑफ एल एन एफ होता है. सो वी ऑल दिस हमें पता है ना. सो एप्लीकेशन में क्या होता है ना, बस अप्लाई करना होता है, चीजें हमें पहले से आती हैं, बस उसकी एक नई कि अगर ऐसा प्रॉब्लम रहा तो यहाँ पे इंटीग्रेट और डिफरेंशिएट करके प्रॉब्लम को सॉल्व करा जा सकता है ना. तो दीज आर जस्ट, हमने अभी तक 8 कवर कर रखे हैं. So by tomorrow we are gonna learn our area under curve. So this is our the things that is left in application of integral. Okay, so thank you guys.